Hi guys, welcome to welcome back to my part two of solving simultaneous equations. This time we're going to use the substitution method. Have a go at that one. And there's a reason why I always reserve the substitution method for last, and it's because students tend to love it so much. When they see the elimination method, they're like, why didn't you show us substitution before? It's because there are times when the elimination method is better to use. It's just that people just love the substitution method. And there's only one type. So let's give it a go. By example, we're going to look at the simultaneous equations 2x plus y being equal to 7. And we're going to also look at x subtract 2y being equal to positive 1. Now, upon comparison of these two equations, you can apply the elimination method by, choosing which variable you like to get rid of and multiplying across by the coefficients of the other. But the substitution method attempts to select an equation. So first up, we are going to call this first equation 1 and this second equation 2. Now, essentially substituting involves choosing a variable and substituting its value into the other equation. Now, if I observe the first equation, 2x plus y. Now, y here is standing by itself. It's standing alone. And if I were to rearrange equation 1, so I can rearrange equation 1 and I can make y the subject. All right, then I will get y is simply equal to 7 subtract 2x. And because that's a new equation, I'm going to call that 3. So very simple. I have taken the first equation and made y the subject. Now that I have an equation where we have y alone by itself being equal to something, what we are going to do is we are going to substitute that into the second equation. So we are going to now substitute y being equal to 7 subtract 2x into our other equation, which is equation 2. So students always make one mistake in this question. They used the first equation to create the third equation, sorry. So those two equations, 1 and 3, have already been used. A frequent mistake that students do is to substitute their value of y or x into an equation which was already used. And then they end up getting 0 is equal to 0. It always happens. I'm just telling you guys up front in case it happens to you. Take note that it's because you substituted into the wrong equation. You always have to substitute into the last equation that was not used as yet. So we have not used equation 2, which means that we simply need to substitute this value for y into equation 2, so that finally we have used all 3 equations. So substituting y is equal to 7 subtract 2x into equation 2 will give us x subtract 2. And instead of y, we are now going to replace it with the value we are substituting it for. And that's the rest of equation 2. Now we have to apply the distributive rule where we are going to expand our brackets here and here. And we are going to get x subtract, well, that's negative 2 multiplied by 7, that's subtract 14. And then we have negative 2 multiplied by negative 2, that's positive therefore x is equal to 1. If you have issues distributing brackets, be sure to look out for my upcoming videos on rules of distribution. Okay, guys, so here we just simply need to group our like terms together. I am saying we have x and plus 4x. That is going to give us 5x. And on our right-hand side, we have 1, as well as I am also going to take this, subtract 14, and I am going to carry it across to my right-hand side, such that it becomes positive 14. Essentially, you are adding 14 to both sides of your equation so that your equation is balanced. And then finally, we'll get 5x is equal to 15. Dividing both sides by 5, we are going to end up getting 15 is equal to 5, 3. So all that work, we have just found the value of x. Now, once you get the value of one of your variables, you can substitute it into one of your 3 equations. Most common students tend to substitute it into their recreated equation. And our recreated equation was 7y is equal to 7 subtract 2x. That's equation 3. So therefore, y is simply going to be equal to 7 subtract our value of x we found to be 3. So we are going to substitute that here. And then finally, we are going to end up getting a value of 7 subtract 6, which is 1. Therefore, x is 3, and we have y being equal to positive 1. I'll do a second example for you guys to get the hang of it. I think I might need to erase my board because these questions tend to take up a lot of space. And then go back up to the top. That's good. Looks good. Okay, so let's look at a second example. All right, so in this example, we have 2x plus 3y being equal to 18, calling that equation 1. Then we have x plus 5y being equal to 23, calling that equation 2. I can recognize essentially if I were to add or subtract these equations, I will not get elimination. I can multiply both equations across by coefficients of variables, but we are going to try to use the substitution method. I am seeing that in equation 2, we already have one of the variables set by themselves. So I am going to use equation 2 to make x the subject. Using equation 2, I will get x to be equal to 23 subtract 5y. I just had to take one step and I needed to carry across my 5y to the right-hand side, rather subtract 5y to both sides. Now I'm going to call this my equation 3, and we have used equation 2 to generate equation 3. So now I will substitute my equation 3 into my unused equation 1. And that will give us, we have equation 1 being 2x. Now remember, we just found a value for x. It's 23 subtract 5y. So we are going to write that here. And then continuing with our equation 1, we are going to write plus 3y equals 18. Take a moment, take a time to check, make sure everything is in place. And once you understand, you can press play. I know some of you guys may be pressing pause. Press play and let's continue. Okay. So from here, essentially, we just have a bit of some algebra, some expansion of brackets, some stuff to clean up. 2 multiplied by 23. Last time I checked, I think it's 46. 5 2s are 10y plus 3y is equal to 18. I am going to group up my like terms together here. That'll give us 46, subtract 7y being equal to 18. Then I'm going to get negative 7y equals, and I'm going to subtract 46 from both sides. And I'm going to use a bit of my calculator here. 18 subtract 46 gives us negative 28. So we're going to get negative 28 on the right-hand side and negative 7y. Now, when students reach questions like these, they tend to be confused and lost with the signs. Now, remember that when you have a coefficient in front of a variable on the left-hand side and you want to carry it across, it's division, right? So you're dividing both sides by negative 7. The sign does not change, guys. It's the operation that you are changing for those of you guys who have learned it that way, okay? And of course, this works out to be 4. So therefore, we have found, we have not found a value for x. We are going to substitute y being equal to 4 into our equation 3. Let me just scroll up back to see what our equation 3 was. It was x is equal to 23 at 5y. Right. So now what we need to do is simply substitute our value of 4 into here. So we will get x is 23, subtract 5 by 4, and that just simply gives us 23 minus 20, which is 3. So therefore, x has a value of 3 and y has a value of 4. And we are done. So the elimination method may perhaps look a little bit daunting in terms of it looks longer, but you'd be surprised. Once you get the hang of this method, people love it. Adults, teachers, students, university students, engineering students, a lot more people love the substitution method way more than the elimination method. But be sure to understand both methods and do the one that's right for you. And if you guys also want to see a tutorial session on the substitution method where I just do a lot of questions, please leave a comment requesting it at the bottom of this video and I will do a tutorial for you guys. So glad to be with you. Take care and see you guys soon. Bye.